It is assembly time. So now that we've made the parts, we're ready to actually put them together. And we're going to be using a few different constraints. And there's, what is it? It's mate and flush. So we're going to be playing around with that a whole bunch, and we're going to talk about using assemblies now. So we're going to go to Autodesk Inventor, and we are going to make a new, not part, we're making an assembly. And the first step in this is that we need to get stuff in to assemble. Go to the place, which looks like a load button because you're actually just loading up the parts that you've already created. I've got my folder with all of my things in it. Note, if you were to move where the parts are, your assembly won't work and you'll have to find that file again. So make sure you don't move the part files after you create the assembly, because all it's doing is saving the address of the part, so it doesn't have to recreate the part in the viewfinder. It saves on memory. So we are going to drop the base plate. Yeah, whatever. All right, we drop it. It's looking good. So the first thing we want to do is we want to lock this into place. So it's called grounding. And let me see. Okay. You right-click the object and you say place grounded at origin. Why do that? Undo, place. I pick the base plate, open, just right-click, place grounded at origin, and now I did it correctly. Next thing we're going to do is place the, I believe, bearing? Yeah. We're going to place the bearing. I just have all these notifications. I'm Mr. Popular. So now I place it into the graphics window, and I got these objects floating around. This one I can just move around, click and drag. This one is grounded, so it's not going anywhere. So the importance of grounding your first object is to prevent your entire assembly from floating around the entire world, because you can move it in weird ways where it'll look like one thing, but then it actually is a different movement. So you want something to stay where you thought it was. Now there's 6 types of movements that can happen. You can be moving in the X direction, the Y direction, or Z direction, or you can rotate in the X direction, rotate in the Y direction, and then rotate in the Z direction. And there's actually some helpful things up here. Joint and constrain. These are going to lock things in place the way you want them. So let's see. What do they want us to do first? So I'll introduce some of these things. So you have mate, angle, tangent, insert, and symmetry. So mate is going to lock things, almost like gluing stuff together in a specific way. Angle will lock them to a certain angle. Pretty straightforward. Tangent, it will take round objects and it will place it tangent to a flat surface. Insert would be if you have cylindrical stuff, or I guess any like screws or objects that you want to have inserted into another on multiple, where there's only one way to fit in. And then symmetry, I've never used that one, but I'm assuming that you would place things based on a measurement for the object. But let's just continue with what we have in our tutorial here. First thing is we are going to play with mate. Now, I want the bottom of this bearing to touch the top of this base plate. So this is where you got to get really good with your movement commands. And what I'm going to do is, well, let me introduce this. Mate is like animals mating. And so they like each other very much and they kiss. And so the 2 surfaces that you tell to mate will sit on top of each other, like 2 animals kissing. Sure. Flush is going to be a smooth surface, almost like if I want my hands to be flush to each other, I put them right next to each other so it's one smooth top surface. And so it's like gluing the sides. So I'm going to use mate right now. I rotate this around. I made it. Makes a little Pinocchio sound. And now it'll slide on the surface. So we have locked it in one direction. So no matter where it is, it looks like I'm raising it above it. I'm actually not. It's moved on the X plane, but it's locked in the Y plane. So now what we are going to do is we are going to lock this using the hores that were bored into the base plate. Something you can also do is you can find the degrees of freedom, the DOF of an object. For that, you go to the View tab, and here you'll see degrees of freedom. And this tells you where things are locked. So it's telling me that I can still rotate in the Y direction, but I don't have arrows showing me that I can move it, so it's locked. But everything else is free. I can still move it around in the other dimensions. Alright, so we've locked it to the surface. Now we want to lock these holes together. So we're going to go back to Assemble. We are going to Mate. And now I'm going to pick I guess you could pick the center of the circle. And I look at the bottom. I'm going to pick the center of this circle too. Oh! Beautiful! Pinocchio! I click Apply, and now it's spinning, but it's getting closer. Excuse me. Let's finish this sucker off. So, for the last one, it looks like we are going to... Let's see. So for this part, I am now looking at the YZ plane, and we are going to attempt to flush constraint. So flush should allow us to put this. Why? It should allow us to click the YZ plane and the YZ plane of the other object. It's not letting me do that. So follow the book, see if you can figure it out. What I'm going to do, just because my brain works better this way, is I'm going to constrain, mate, and here at the center of this circle with the center of the inner circle. Boom. Does the same thing. Why overly complicate it? Here, it's locked in, it's not moving anywhere because it's locked to the grounded piece, which isn't moving anywhere. So we're set to go. Next up, we have the, let's see, place. We're going to place, I want to say the bearing. All my, that's not it. Place. Cap, no, collar. We're going to place the collar. Okay, collar is going to go on top of this sucker. So what are we going to do? We're going to constrain it, except this time we're going to insert. So we have to choose aligned or opposed. And for this particular one, I believe we are choosing, is it opposed? So I've always had problems with picking exactly what I want for the insert command. I undo, I go back, I fix it. So what I'm going to do is I'm going to choose the outer rim, and I'm going to choose this rim, and here it's inserted. So here I'm using opposed, but I don't understand how that's opposed. You know, that's why my brain doesn't get it. So if I need to, I could say insert, and here, oh, okay, that means that it's going into it. Aha. Opposed means that they are going into each other. Aligned means that they are moving the same direction. So, wow, okay, learned something. So I say apply. Great, we are nearly there. Now we got to screw it up. And we do that with our cap screws. I have all my little warnings. And I'm going to drop 2 of these bad boys here. And it's showing me the directions that it's free. Because everything else that's locked, this is not. So we go to the screws. Now, we are going to okay, so we've placed the components. They have 6 of them. assemble as shown in the picture below. I thought they were going to be a little fancier. That's okay. So, constrain, insert that, that. And here I go again, getting messed up. Cancel. Okay, constrain. I'm going to insert the bottom of it into the bottom of that. No. Now I go to aligned. No. Cancel. Third time's a charm, right? So I say insert, opposed. I'm going to pick the inner edge is going to be opposed to that. That's looking closer. Insert. This inner edge is going to the bottom inner edge. That's baby. Say apply. Cool. Let's do the same thing with the other one. And now it's going to take one shot because I know what I'm doing. Good. Apply. Done. My screws are rotated 90 degrees compared to theirs. Still think it's okay. So I go like this. And now, oh, everything's locked in place. Except I guess you can twist them. Be interesting if it had the screw command that you could get to screw in or out. Anyway, we are nearly done here. So what you can do is you can make an exploded assembly, something that it has all the parts and it blows up a bit so you can see everything. So what you could do is you click free move, and free move will allow you to freely move the fella. And this is handy if you want to just show where things go. So here, let's see if I can do that. Yeah, that's further up, and here I'm going to move it up. That's close enough. Close enough. Why not? Some other things I got to show you too. So you can print this picture, you can save a PDF. But then if you want to get it back to normal, you don't have to meticulously get it back in. Wonder, yeah. All you have to do is say auto update. Once again, that pops up in the fast icon bar, quick access toolbar. There it is. Now, editing the components. What you can do in this is you can look at you'll notice that all the different combinations that we included or that we used to actually produce this are included in the side here. But something you can do in here is you can actually edit like you would in a part file. So cap screw and 3D model. No, that's starting new sketches. I don't want to do that. I want to edit. So I'm going to the bearing, and now I'm going to right click it, edit, and this is going to be like a mini version of the part creation. So now what I can do is I can edit my sketch, and you're supposed to make these screw holes smaller. I'm pausing because I want to make sure I get all the details for you. Turns out we're going to need a video 3 because I got about 10 pages to go. So at this point you have now assembled your parts. See you next video.